Hello everyone, I'm going to talk about the impacts of climate changes on Lake Urmia in Iran and its nearby cities and ecosystem. In the late 1990s, Lake Urmia in northwestern Iran was twice as large as Luxembourg and was the largest saltwater lake in the Middle East. Since then, it has shrunk substantially and was sliced in half in 2008. In the current work, we study some of the main reasons for its drought and its consequential hazards on a nearby ecosystem and cities. In recent decades, studying lake changes has found a special status among countries and even at international level. There are several reasons associated in declining of lakes. One of the most notable reasons for such incident has been severe climate change. Besides that, anthropogenic effects such as overexploitation of water resources, overcultivating, and building dams across the river or stream to hold back water from entering the lake could result in drought. In this study, we investigate Lake Urmia drought in the last 10 years due to ineffective water management and intensive drought. Lake Urmia has severe restrictions on water resources and becoming saltwater increasingly, which will cause ecological, health, social, and economic problems for cities, natural habitats, and plantation near the lake. Lake Urmia is the 20th largest lake in the world, based on the occupied area and the second most hypersaline lake. This lake is located in the province of Azerbaijan, west of Tabriz and east of Urmia, Iran. Nearly 30 small and large rivers flow into the lake. This lake is considered as an internationally registered protected area since 1968. Shrinkage of the Lake Urmia occurred not only as a result of frequent drought and aggressive upstream water use and storage, but also due to anthropogenic impacts of arrogant and uncoordinated development activities by nearby provinces in an unreasonable competition for using natural environment. In here we have the location of Urmia's water catchment in Iran. Lake Urmia drought has affected a number of plant and animal species in its catchment area. Besides that, its negative impacts on human activities are undeniable. In Fig 2, we have a series of images from Urmia water catchment from 2010 to 2019. From 2010 to 2014 and from 2017 to 2018, we can see severe decline in basin of Lake Urmia. These serial images are collected from Google Earth. In order to monitor the onset and duration of agricultural drought, Vegetation Condition Index or VCI, Temperature Condition Index or TCI, and Palmer Drought Severity Index or PDSI have been used. Fig 3 shows agricultural land in Urmia water catchment area. Three distinct types of farming found there are included rain-fed agriculture, irrigated agriculture, and a mixture of both techniques. Rain-fed agriculture, which is the predominant type of cultivation in this area, depends heavily on rainfall patterns. On the other hand, irrigated agriculture applies water from other sources, such as fresh water from streams, rivers, and lakes or groundwater. Increased water variability and climate changes make local farmers more vulnerable. In light of climate changes adaptation strategies, it's expected to see more agricultural land that their cultivation pattern is a spectrum between rain-fed and irrigated agriculture in near future. And here we have land surface temperature or LST. The land surface temperature plays such an important role in environmental and climate studies. The LST demonstrates the temperature of any surface on Earth. It is a compound of vegetation and bare soil temperatures. All 10 years of available LSD data from 2010 to 2020 have been processed and time series extracted to show the trend of land surface temperature changes throughout this area during these 10 years, as you can see in figure 4. The other index is Temperature Condition Index, or TCI, which could be used to determine the stress on vegetation caused by temperatures and excessive wetness. TCI varies from 0 for extremely unfavorable conditions to 1 for optimal conditions. TCI was developed based on LSC products by calculating following formula. TCI is equal to maximum LSD minus LSD divided on maximum LSD minus minimum LSD. In here at figure 5, we have the time series changes from 2010 to 2021. The other index is Normalized Difference Vegetation Index, or NDVI. Which can be used to record and quantify the changes which may happen in vegetation coverage due to changing climate conditions. Positive NDVI values demonstrate vegetated areas, and 0 and negative values are bare soils and water bodies. NDVI reveal distribution of vegetation based on a characteristic reflectance pattern of green vegetation. This simple numerical indicator can be used by calculating this formula. NDVI is equal to near infrared band minus red band divided on near infrared red band plus red band. And in figure 6, we have the time series changes for NDVI from 2010 to 2021. Vegetation Condition Index, or VCI, is among the most commonly used satellite data products for evaluation, monitoring vegetation cover, condition, and changes. It's based on relative NDVI changes in the target area. It provides more accurate results compared to NDVI for monitoring drought on a regional scale. In here, we have the formula for calculating VCI. As you can see, VCI is equal to NDVI minus minimum NDVI divided on maximum NDVI minus minimum NDVI. Palmer Drought Severity Index, or PDSI. PDSI estimates relative dryness by using available temperature and precipitation data. It's a standards index that generally varies from -10 for dry condition to +10 for favorable condition. In here, in figure 8, we have time series changes from 2010 to 2021. Lake Urmia shrinking got severely intensified from 2010 to 2014, as I told you before. In 2014 to 2016, due to favorable weather conditions, increasing rainfall, proper dams management, its drought decreased. Although climate changes contributed in drought in this area, as you notice in time series which have been brought before, some years indicate lower VCI, TCI, and PDSI values. However, anthropogenic activities are still the main reason of drought in this area. If decision makers do not change their policies, in this case, the northwest of Iran included West Azerbaijan, East Azerbaijan, and Kurdistan provinces will face irreparable health, social, and natural hazards. Thanks for your attention. If you have any question, you could send your questions to my email address, which have been brought in my YouTube channel. Thank you so much.